We've added all the mutations for our track data at this point. We can like tracks, create tracks, edit tracks, and delete tracks. But let's revisit how we're updating the UI in response to a successful mutation. Let's head to, first, our create track component. And here we executed our create track mutation. We did what we needed with state, but that alone didn't update our UI. In fact, we had to use RefetchQueries to refetch our get tracks query. So we had to get all of our tracks data once again. And the same thing applied for deleting tracks within our delete track component. We created our delete track mutation, and when this was run, we didn't immediately see our page update. Once again, we had to run, using RefetchQueries, our get tracks query. But remember that our two other mutations were slightly different, and those are like track as well as update track. In fact, here we didn't need to import the get tracks query. Instead, we saw that whenever a track was updated, whenever we ran this mutation, if we look at the mutation component, we didn't have to provide RefetchQueries whatsoever. So why is this the case? What's happening here? To understand this difference between our mutations, we need to understand Apollo in greater depth and how it's set up. Track list, and it also caches the results of other operations that our users performed. Now, when a mutation is performed, Apollo's cache isn't updated in real time. For the cache to be updated with the latest data that comes from the most recent mutation, the user has to reload the page, or additionally they have to refetch the query. So when we were using RefetchQueries, both within create track and delete track, we were simply updating our cache by making another network request for the latest track data. However, there's another and more performant approach to updating our cache instead of using RefetchQueries, and that is the update function. And we can provide update on any one of our mutation components. So update is what's going to prevent our app data in our Apollo cache from being out of sync. The reason these two sets of data are out of sync at times is because often we're trying to perform an update, we're trying to change our data in a way that depends on data that's already stored within the Apollo cache. And this is the case with both our create track mutation and our delete track mutation. For basically any part of our app where we need to delete or add items to a list, we're going to need to use the update function in response to a successful mutation in order to update our UI with that new data. So update is a great option because instead of making another network request or multiple network requests with RefetchQueries, all we have to do to update our user's view in response to a successful mutation is with update we can take our cache data from the Apollo cache, and in the case of the create track mutation, we can just add that one piece of data that was added, and in the case of delete track, we can simply remove it. So this makes update far more performant than resorting to RefetchQueries.